welcome back. We're just talking about proving this. So I think this is a great way to practice writing a proof. We start with a given, and then we copy and paste this stuff right here. A, B, C, D is a parallelogram. I'm just going to abbreviate, okay? So if they're a parallelogram, I think we usually follow up with, and you might not know this, but that's why I'm making a video, the definition of a parallelogram. It's got that word parallel in it, so I'm betting that we're supposed to write opposite sides are parallel. So the definition of a parallelogram would have to mean that side BC is parallel to side AD. And mathematicians are too lazy. They put this little symbol to mean parallel. We also know the orange ones. We also know side AB has to be parallel to CD, because that's how it got its name, parallelogram, because its opposite sides are parallel. That's the definition of a parallelogram. Now that we know that, I think that we know from class that if we have all these parallel lines, they're either going to be the same size or different size, and then we can set that up and solve. So if we trace this here, right, angle A, it looks like it's a perfect fit. Angle C. We also need to prove whether or not B is congruent to D. So is B, angle B, congruent to angle D? And it looks like it is. So prove always comes last, but we never write prove. So I'm supposed to prove angle A is congruent to angle C and angle B is congruent to D. Okay, but I can't write proof. My last step is, why would those be equal? So I'm thinking that one of the reasons we talked about today, so I think it's actually a two-step to get there, and I would never think you could get there, but we'll eventually get here together. So if I think about this, I know that if these are parallel, I could say, if you were in the pink group, you might be saying these look like they're on the same size as the transversal. If I extend these lines here, the pink group might say, you know what, it looks like angle A and B are my same side interior angles. See how they look inside those parallel lines? They're different sizes. So I think I could say, and I think we should say, different size, two angles set equal. And that was the only one we learned. So I actually think angle A plus angle B add up to 180 because they're different sizes, and they're different sizes because they're called same side interior angles. All right. I also know if I twist my paper, so I don't know if in the quiz you had to twist your paper, but you might notice again, angle B and angle C also look like they're on the same side. So if I extend these lines, I see, wait a minute, it kind of looks like angle B and C are also on the same size if this is the transversal, and one's big and one's little. So I think I could also say angle B and angle C, one's big, one's little, they should add up to 180. And are you seeing something interesting here? Wouldn't a clump of stuff that's equal to 180 and another clump of stuff that's equal to 180, shouldn't they be equal to one another? That's called transitive. Okay, so using transitivity, I think I could set these both equal to each other. It's kind of a logic thing. So A plus B and B plus C. And now I almost have this first one. I think, maybe I need one more step here. I think, I wonder if you see this. If I subtract angle B on both sides, that would be called subtraction property of equality. And angle A would have to equal angle C, and that's what I was trying to prove. Subtraction property of equality. Now, I would have to do that again with this A and B, but I think the steps, I've proven this to be true. And I think for today's homework, that's going to be enough. I've proven angle A is equal to angle C by merely subtracting angle B on both sides, whatever that might be. Maybe angle B is 60 degrees. I can subtract 60 on both sides of an equation, so I can subtract an angle measurement on both sides of the equation. Pretty cool. Now let's look at this last one. This is also maybe a little challenge question, so I'm interested to see what kids come up with. It says 3 parallelograms. Ooh. So this is parallel to this, and all these lines are parallel. And all these lines are parallel. And so they're saying these 3 are parallelograms. They're hinged together at the vertex. So to create this arm, collapsing an exploratory space robot, what is the measurement of angle 1? Explain how you found your answer. So let's notice something. They said this is this 122. Okay, so this picture's too small. So in geometry, when my picture's too small, I'm just gonna draw it a lot bigger so I can understand it a little bit better. Okay, so I blew this up. They're saying this is angle 1. So is that big or small? Big or little? It's looking little to me, isn't it? And this angle 122, that's looking big, isn't it? So once again in our lesson, if they're different sizes, they're going to add up to 180. If they're the same, we set them equal to each other. So using my patty paper, angle 1 does not look like it's equal to that angle. So I'm not going to do that. I'm going to set them, add them together, angle 1 and the angle that measures 122 has to add up to 180. And I'm going to subtract 122 on each side. So the measure of angle 1 is equal to 58. Awesome. Just make sure you can see that. So everything in the lesson kind of hinged on just a simple card. If they're the same size, set them equal to each other and solve. If they're different sizes, we're going to add the 2 angles together and set them equal to 180. So 57 and 123 on this question were the measurement of these 2 angles because they were different measurements. On this question, 122 and 58 were different measurements because they're different sizes, but together you add them up to be 180. Thanks so much for joining us.